Alright guys, we're still doing some physics 184 today. This is still chapter 28 and we're on question 12 on mastering physics. So let's get right into it. Okay, so this question is giving us that a 10 microfarad capacitor is initially charged to 30 microcoulombs and it's discharged for a 1.4 kilo ohm resistor. And it's asking us how long does it take to reduce the capacitor's charge to 15 microcoulombs. Well, with these problems, and any of these problems, you should write down what we have. And by the way, here's the answer, guys. Just make sure I'm doing it right. Okay, so let's get going. So the capacitor, I'm just going to write as C. That's going to be 10 e to the negative 6. Let's keep it on in, consistent units, right? So that's going to be farads. So one thing to know, guys, is 1 farad is actually equal to 1 coulomb squared divided by joule. Okay, but 1 joule, right? 1 joule, that's equal to, let's see here. 1 joule is equal to 1 volt times coulomb, okay? So 1 farad is actually equal to 1 coulomb squared over volt times coulomb, and these coulombs with the coulomb square cancel, so it's that 1 coulomb per volt is equal to 1 farad, okay? So that's the units I'm going to use so we can cancel everything out to get something in time, in terms of time. So it's just going to be 10 to the minus 6 coulomb per volt. Okay, so and then we have the initial charge, so it's going to call Q now because it's initial. That's going to be equal to 30 e to the minus 6. Remember consistent units, and that's going to be coulombs. And resistor is denoted as R. It's going to be a 1.4 e to the 3, keeping consistent units, ohms, and 1 ohm. Okay, 1 ohm, that's equal to 1 volt over amperage, right? So it's keeping just having our units as getting our units as most basic as they can be, so we can get something in terms of time. Now it's asking us how long does it take to get in time. So when we have the capacitor's charge, which is the final charge, is 15 e to the negative 3 coulombs. Okay, so how do we go about doing this now? Well, we have to know the equation for this. So one equation to know is Q is equal to Q naught e to the minus t over tau, and this looks like an exponential decay function, right? So what we're going to do is we're going to be using this, but what is tau, right? T is time, we know Q naught and Q. Tau is actually R times C, a resistor times the capacitor, so that's also another equation we're going to be plugging in. Let's go ahead and rearrange this equation to solve for time. So if we divide Q naught to both sides, and then we take the natural log of both sides to get rid of the E, we're going to get natural log of Q divided by Q naught equals to minus T over tau, but instead of tau, let's go ahead and put in RC. To get tau by itself, or not tau, to get T by itself, we can multiply both sides by RC in the negative. So we're just going to get T is equal to minus RC natural log of Q divided by Q naught. Okay, so now we can just begin plugging stuff in. Let's see, I'm pretty sure I missed the seconds here. Okay, now we're good here. So we have T is equal to minus R. Well, that's just 1.4 e to the 3. And amps, right? What is amps in? Well, 1 amp, right? 1 amp is equal to 1 coulomb per second. Okay, but it's at the bottom, right? So it's actually going to be equal to coulomb per second. So if we rearrange this, we're going to get V times seconds over coulomb. So it's just going to be V times seconds over coulomb. That's our R. And the C, that's just going to be 10 e to the negative 6 coulomb per volt. And then we're going to have the natural log, and then these units are just going to be here. Let's see, what is Q? These units are going to cancel. This is going to be unitless, right? Because the coulombs is going to cancel this coulomb. So it's going to be 15 e to the negative 3 coulombs divided by Q naught, which is 30 e to the negative 6 coulombs. These coulombs cancel. This volt and this volt cancel, and this coulomb cancel. So we're left with seconds, right? So if I were to plug this all in the calculator, which I'll do right now, e to negative 3 divided by 30 e to negative 6, natural log of that, times 10 e to negative 6 times by negative 1.4 e to the 3. We get, oops, I multiplied it improperly. I have the wrong number here. Divided by 30 e to negative 6. Aha. So this is actually not negative 3. That's negative 6. You guys are probably wondering what's going on there. That's negative 6. That's micro. It's not milli, right? So 15 e to negative 6 divided by 30 e to negative 6, natural log of that, times 10 e to negative 6 times negative 1.4 e to the 3, and then we get 0.0097 seconds, which if we get it in milliseconds, we move it 3 places over, 1, 2, 3, so that's going to be 9.7 milliseconds, which is exactly what we had here. Thanks, guys.